Hello students, in this lecture we will study what is a linear time invariant system and what is a linear shift invariant system. So in signal processing we can classify systems in two types. In first type of systems we process continuous time signals. These kinds of systems are known as continuous time systems or analog systems. And in another type of systems we process discrete time signals, and these kind of systems are known as discrete time systems. So let's start with a continuous time system. We will take a specific case of signal processing system that is having property of linearity and time invariance. So we can say that a system that is having these two properties means that system must be linear and as well as it must be time invariant. Got it? So that system is known as linear time invariant system. Let's understand what is that linearity and time invariance. Now suppose there is a system, continuous time system, and I am having input xt, okay, and corresponding to this xt I am getting a output y of t. Got it? But if I will put the input signal like this, ax1t plus bx2t, what will be the output corresponding to this input? So if any system that is giving output in the form like a of y1t plus b of y2t, okay, so then this kind of system is known as linear system. Let's understand in detail. If I will give this system an input x1t, then it will give an output y1t. Means if I will give a input x1t, then this system will give an output y1t. If I will give a input signal x2t, then this system give an output of y2t. Now if I will put an input ax1t plus bx2t, then this system will give an output of ay1t plus by2t. Means the constant has come out. Okay, so what kind of property it is showing? It is showing a linearity property. Got it? So this system is known as linear because this is satisfying this condition. Got it? Now we will understand that what is the property of time invariance. So time invariance is what? If I delay this input, suppose in place of x of t, if I give a signal that is something like x of t minus capital T. If I give an input x of t minus capital T, then the property or characteristics of the system will not change. It will give corresponding output like y of t minus capital T. Got it? So any system in which if we are changing the input as x of t minus t in place of x of t, then if it is giving the output as y of t minus tau, means it has given the same output but delayed by capital T. Got it? So characteristics is not changed when we delayed the signal. Got it? So with time the characteristics of the system is constant. So these kind of systems are known as time invariant systems. By name also you can judge it. Time invariant system does not vary over the time. Got it? So the system which is having both the property linearity and time invariance is known as linear time invariant system in continuous time systems. Got it? Now if we talk about discrete time system, then both the systems are just similar. The only difference is this system is for continuous time signals, this system is for discrete time signals. Okay, so now see, what will happen to this? Now you can see the input signal is x of n, and it is somewhat different from this signal. So this difference is to discriminate between a discrete time signal and a continuous time signal. Basically, for a continuous time signal, we use small t for time, okay, and parenthesis. We enclose it in the parenthesis. But when we talk about a discrete time signal, then we take time instances, and those time instances are represented by small n in place of small t, and it is enclosed by square bracket. Okay, so when you will see this kind of representation, then you will understand that this is what? A discrete time signal. And if you will see this kind of representation, then you will understand that that is what? Continuous time signal. You need not to mention there. Okay, so now let's come over the topic. X of n, when I will give an input x of n, then this system will give output as y of n. Okay, and it is linear if it is showing both the properties like linearity and time invariance. If this system will show both the property linearity and time invariance, then it will known as linear shift invariant system. Linear shift invariant system. So there is no difference, only one difference is there, that linear time invariant system is processing continuous time signals and linear shift invariant system is processing discrete time signals, and the same properties will be followed here. Like I'm giving an example. If in place of x of n, if I put an input like a of x1 of n plus b of x2 of n, okay, x2 of n, then it will give an output as y, means simply the constant value will come out and signal corresponding to x1 of n. If we will give in this system x1 of n, then output will be y1 of n. Okay, so in place of this, output will be y1 of n and plus b means the constant value will come out and then it will be multiplied by the output corresponding to x2 of n, means y2 of n. Got it? Shift invariance. What is that shift? Time invariance, sorry. Now, what is time invariance? Okay, let's see. What is time invariance? Suppose we have given a delayed input. Delayed input means x of n minus t naught. Sorry, not t naught, n minus n naught. Here for time period we will use capital N. Okay, here for the time period we will use capital T. So x of n minus n naught, many places you will get it will be represented by, at many places it will be represented by capital N only. Okay, so now the output will be y of small n minus n naught, means no characteristics is changed. The output is also delayed, okay, but the characteristics of the system is constant. So the characteristics of system is not changing in this discrete time signal by varying the time or delaying the time of the input. So these kind of system are also known as time invariant system. Okay, when these both properties are combined, then the system is known as linear shift invariant system. Now I hope you have understood the concept of linear time invariant system and a linear shift invariant system. In the next lecture we will study how we will characterize these systems. Thank you very much.